All right, well, we've only got 8 of us, but it's been like 7 minutes. So everybody else is like really late, and we're going to get started without them. Yay, first hour. Go to our grade screen and see where we're at now. Scrolling way down. Last week, we had matrix row operations, add and subtract matrices, matrix equations, addition and subtraction. This week, we have multiply matrices by scalars, matrix equations, scalar multiplication, and our first quiz. We'll have another quiz next week. We're getting quizzes pretty quick, but that's because we also have a quiz 3 coming up the week after that, and the week after that's quiz 4. So we got quizzes for the next 4 weeks until we wrap up matrices. All right, this week we just have one folder to do, the multiply matrices by scalars. We'll see how many lessons are in there. Activities. Okay, we did the adding and subtracting matrices. So we have, there's another folder before the quiz, but there's no assignment in there, but we need to go through those lessons because we'll need them for the quiz. So we have 2 folders to go through, but there's just 2 assignments and the quiz. So let's look at the multiplying matrices by scalars video lesson. All right, let's see what this is all about.
Now that we know what a matrix is, let's see if we can start to define some operations on matrices. So let's say I have the 2 by 3 matrix, so 2 rows and 3 columns, and the entries are 7, 5, -10, 3, 8, and 0. And I want to define what happens when I multiply 3 times this whole thing. So first of all, let's get a little terminology out of the way. The number 3 in just the everyday world, if you weren't dealing with matrices or vectors, and if you don't know what vectors are, don't worry about them just now, you would just call that a number, or you would call this a real number. It's just a regular number sitting out there. But now in the world where we have these new structured things, these matrices, these arrays of numbers, we will refer to these just plain old real numbers that aren't part of some type of an array here. We call these scalars. We call this a scalar. So essentially what we're defining here, we don't know, I haven't said what this is actually going to turn out to be, but whatever this turns out to be will be a product of scalar multiplication, or we're multiplying a scalar times a matrix. And so how would you define this? What do you think this should be? 3 times this stuff right over here. Well, the world could have defined scalar multiplication however it saw fit, but one way that we find perhaps most obvious and most useful is to multiply this scalar quantity times each of the entries. So this is going to be equal to 3 times 7 in the top left, 3 times 5, 3 times -10, 3 times 3, 3 times 8, and 3 times 0, which will give us, it didn't change the dimensions of the matrix, it didn't change, I guess you could say, the structure of the matrix, it just multiplied each of the entries times 3. So the top left entry is now going to be 21. The middle entry, or the entry in the middle row top column is going to be 15, -30, 9, 24, and 0. So when you multiply a matrix times a scalar, you just multiply each of those entries times that scalar quantity.
All right, there you go. It is that simple. With scalar multiplication, you just take whatever the scalar number is and multiply it by every number in the matrix there. All right, so let's go to the second lesson, which should be just the written lesson talking about the same type of stuff here. So, okay, close this little thing here. As usual, it starts with what is a matrix? What you should be familiar with. This is a 2 rows, 3 columns, so we call this a 2 by 3 matrix. It has links to that intro to matrices lesson and how to add and subtract if you want to review. What you'll learn in this lesson is we can multiply matrices by real numbers, scalars, and scalar multiplication. So when we work with matrices, we refer to real numbers as scalars. The term scalar multiplication refers to the product of a real number in a matrix. So here it is. Given that A is 10, 6, 4, 3, let's find 2A, which just means multiply A times 2. So 2A is 2 times A, which is 10, 6, 4, 3. So 2 times 10, 2 times 6, 2 times 4, 2 times 3, which of course is 20, 12, 8, and 6, which is just twice what it was originally. All right, so here's our problems for, let me open the chat so I can see what you guys put in there. Let's see. Given B is -4, -2, 7, and 1, find -3B. So give me the first row. And this is where we struggle sometimes. When there's negatives, when I see people miss things in matrices, it's usually they forgot about the negatives. So you got to treat that properly when you have negative numbers that you're dealing with. Otherwise, this is just elementary stuff. We're just multiplying two numbers together. But we still get a little messed up sometimes when there's negative numbers involved. So what is the first row of -3B? All right, did everyone leave class? It's just going to be one of those days I need to take attendance in the middle of class because everybody walked away from the Chromebook. Is that why all your cameras are off? I need to make cameras come on for attendance, don't I? So all you folks have turned off your cameras and walked away. Thanks, Jonathan. Jonathan gave it a shot. Anybody else still in class? Thanks, Elijah. Hi, Kristen. We're doing scalar multiplication here. Cooper thinks Jonathan is correct, but Jonathan wasn't quite sure. -3 times this matrix. So -3 times -4 is a positive 12. -3 times -2 is a positive 6. Then our second row, we would take the -3 times the positive 7. We've got a -21. -3 times 1, we know that one, -3. And that is absolutely correct. Look at this one. This kind of freaks some people out sometimes too. Thanks, Kristen. Given C is this 3-row, 1-column matrix, -42, 27, -3, find 1/3 C. Multiplying C by 1/3. Now, the nice thing is with 1/3, that's the same thing as dividing by 3. Multiplying by 1/3 or dividing by 3 is the exact same thing. So what are the three numbers going to be for our answer on this matrix? Starting with the top row at -42, 27, and -3. Be brave. Give it a shot. Well, people don't like fractions sometimes, but I'm confident you can do this. You guys are seniors. 1/3 should not be intimidating at this point. Jonathan's jumped out there and got an answer for us. And did well, paying attention to the negatives. Like I say, a lot of times we forget the negatives. 1/3 times -42. Just the same thing as dividing -42 by 3. It is -14 when you multiply it by 1/3. 27 times 1/3 is 9. -3 times 1/3. What's 1/3 of -3? It's -1. Check. We're good, check. And that's it. That's all the practice they give us on that. So now we have our two assignments: multiply matrices by scalars and matrix equations, scalar multiplication. So let's go to our first assignment. One of those where we got to copy and paste. So when I go here, I see that I'm still logged in up top. So it's going to keep track of my score for me. Ready to practice. Let's go. Find the product 4 times, and we have this matrix of -1, 3, 4, 1. So let me do this. -1 times 4 is -4. 4 times 3 is 12. 4 times 4 is 16. 4 times 1. Let's see how we did. Yay. Second question. Now this gets a little trickier. I want you to answer this one. What does x equal and what does y equal? This is the one where I see students get confused a lot. And don't get confused. This is negative 1/4 times this matrix. And the answer is this matrix. So negative 1/4 times x equals 5. So what is x? If negative 1/4 times x equals 5, what is x? Let's see what you get on that, because this is where we struggle sometimes. If you need to, write it down as just a math problem, put pencil and paper, and do negative 1/4 x equals 5 and solve for x. I might do that for those of you who really go, wow, how do you do this? I'm lost. I'll show you how to do that, because I don't like the students get confused in this. Marissa's got an answer out there. So let me put this up on the screen just to show you folks that get a little confused over some of these. Not everyone does, but some people do. And so we had negative 1/4 x equals 5, right? Because we pulled it out. We had negative 1/4 out front of the matrix, and we had this matrix that had x and then two other things, and it equaled a 5 and then two other answers, right? So we're just looking at the negative 1/4 times x, because there's just scalar. Negative 1/4 times x equals 5. So that's just this problem right here. And if I want to get rid of the fraction, I can multiply by the denominator. I also want to make it a positive, so I'm going to multiply it by negative. So if I multiply by a negative 4 on both sides, negative 4 times negative 1/4 cancels each other out, and that's just x. That's just 1x. 5 times negative 4. So x equals negative 20. That's our answer, which Marissa was on top of. She got that. Then we have negative 1/4 times negative 32 equals y. You see, we didn't really have to do the middle one. Negative 1/4 times 12 equals negative 3. They already had that one complete. But negative 1/4 times negative 32. Well, we know it's a negative times a negative, so our answer is going to be a positive. And what is 1/4 times 32? It's positive 8. If you needed the calculator, you could pull up the calculator, and you could say, what is 1? If you put it in parentheses, 1 divided by 4, see, that's 1/4 times 32. It's 8. So you could use the fractions of the calculator, put it in parentheses. And we could have done the negative 1/4 as well. Then parentheses, negative 1 divided by 4. Oh, I missed the divided by. Parentheses, negative 1 divided by 4. See, times negative 32. We're going to put the negatives right in there and get the positive 8. So if you need the calculator for the fractions, use it. Just make sure you put the fraction in parentheses. All right, next question. Find the product. 1/2. 1/2 we kind of like as a fraction because we can do 1/2, right? What's 1/2 of negative 4? Well, that's negative 2. What's 1/2 times 6? It's 3. What's 1/2 times 2? It's 1. What's 1/2 times 0? Well, half of 0 is still 0. All right. Oh, here's another x and y. So I'm going to let you guys do this one. We got a 2-row, 3-column. So 2 by 3. Of course, the answer is going to be a 2 by 3. And we're multiplying this entire matrix by negative 2. So what is x? What is y? Negative 2x. So we're looking at the second row, first column, equals 8. Negative 2x equals 8. And negative 2y equals 0. So what is x? if negative 2 times x equals a positive 8? Yeah, we're going to struggle today. Got to go back to Algebra 1 or elementary school. Negative 2 times x equals 8. We can break it down like we're Algebra 1 students, like we're in 8th grade. I divide it by negative 2 to solve for x. Negative 2 divided by negative 2 is just 1, so this just equals x equals 8 divided by negative 2. If you need to get your calculator for that, look, x equals negative 4. X equals negative 4. Because negative 2 times x will be 8. So negative 2 times negative 4 is 8. What about negative 2 times y equals 0? Well, the only thing y could possibly be, if we multiply it by any number and end up with 0, is y has to be 0. Negative 2 times 0 is 0. Anything times 0 is 0. So, good work. So here's the page you want to screenshot. This is 4 out of 4 correct. So let's take a picture of that. That's what we want to turn in. That's what we want to go back to Buzz with. 4 out of 4. All right, scroll down. There it is. Submit my work. Okay, so we're done with the first assignment. Now we've got matrix equation scalar multiplication. All right, let's see. This one, like the one last week, is the other assignment I have found that has not been working all the time. Now, it is working for a lot of students, but not everybody. So we'll see if it's working today for us in class. Close that. All right, 4 questions. So far, so good. This is a 3 by 3. This is a 3 by 3. So x should be a 3 by 3. So let me write this out to show what it's got. 3x plus this matrix, negative 1, 1, 0. This requires a little bit of work, so I'm going to write it down so we can step through what it's talking about. Negative 1 equals this matrix over here, 11, 4, 9, 2, negative 17, 0, negative 14, negative 12, and 5. Okay, so this problem says 3 times x plus this matrix equals this matrix. And what it's telling us is x is actually a matrix. And we have to fill in the matrix that is x. This is x. And it's a 3 by 3 because it has to be the same size because we're adding it to another 3 by 3 and we're getting a 3 by 3. So you really got to take it out one thing at a time. What's the first one? So it's 3 times whatever that x is plus a negative 1. So that really means we're subtracting 1 equals 11. Just solve that for x. 3x plus a negative 1. So 3x minus 1 equals 11. So I add 1. 3x equals 12. Divide by 3. So this one is 4. That's the first number of my matrix. 3 times 4 is 12. Plus negative 1 makes it 11. And that's what it needed to be. All right, 3 times, what's this one? 3 times x plus 1 equals 4. Three x plus 1 equals 4. 3x equals 3. Well, 3 times x equals 3. X must be 1. 3 times 1 plus 1 equals 4. 3 times something plus 0. So I don't even need that. 3 times something equals 9. Well, 3 times 3 equals 9. Even if I add 0 to it. Second row and third row. We got to come up with all those. 3 times something plus 8 equals 2. All right. Solve for x minus 8. 3x equals negative 6. So this must equal negative 2. Negative 6 plus 8 is 2. Okay, 3 times something plus negative 5. So really it's like subtracting 5 equals negative 17. So add 5. 3x equals negative 12 when you add 5 to negative 17. So this must be negative 4. All right, going well. 3 times something plus 9 equals 0. 3x plus 9 equals 0. Subtract 9. 3x equals negative 9. So if you divide by 3, this is negative 3. 3 times negative 3 is negative 9. Negative 9 plus 9 would be 0. All right, 3 times something plus 4 equals negative 14. 3x, I'm just going to call this x, 3x plus 4 equals negative 14. So subtract 4 from both sides. 3x equals negative 18. Divide by 3. X equals negative 6. Negative 18 divided by 3. Okay. 3x plus 3 equals negative 12. Subtract 3. You may be able to do a lot of these in your head, but if not, this is how you do it. X equals negative 5. Then 3 times something plus a negative 1. So subtract 1. 3 times something minus 1 equals 5. Well, that'd be 2 then, because 3 times 2 is 6, plus a negative 1 would bring it down to 5. So this is our answer for matrix X. So let's type that in and see how we did. 4, 1, 3, negative 2, negative 4, negative 3, negative 6, negative 5, and 2. All right. Here's our moment of truth. There it is. Great work. That's exactly how you step through that. X is a matrix. And you just have to do them one by one. Let's look at the next question. Okay. Here's where it's messing up on us. We cannot finish this assignment. 1/7 times x minus 127 negative 1 equals 3 negative 254. The answer is going to be a 2 by 2 matrix. X has to be a 2 by 2 matrix to subtract another 2 by 2 matrix, and they gave us a 3 by 3 matrix. This problem is not going to let us work it. So we can go back and take a screenshot to show Mr. Brock, the website is messing up. Website's messing up, so please give me credit. Can't do it. I say, okay. Now let's look at it to see what the answer would be, just so we can work on our skills. Because this one has a fraction, and it might work for you, and then you're like, oh gosh, how do you do that? I'm going to put another sheet of paper up here. So X is a matrix that's the same size as these. And 1/7 X, 1/7 X minus 1 should equal 3. Add 1. 1/7 X equals 4. How do you get rid of a fraction? You multiply by the denominator. So multiply by 7 on both sides. 1/7 times 7 is just 1. So X equals 28. 28 would be our first entry. Because that's how you get rid of a fraction. You multiply by the denominator, both sides. 1/7 X minus 2 equals -2. Add 2. 1/7 X equals 0. So this just has to be 0. Because that's the only thing it can be. If 1/7 times X equals 0, X has to be 0. Let's see. 1/7 X minus 7 equals -5. All right, moving to the second row. Plus 7. 1/7 X equals 2. Multiply both sides times 7. X equals 14. And then 1/7 X minus -1 minus -1 would mean +1. We're subtracting a negative equals 4. So 1/7 X equals 3. X equals 21. So 28, 0, 14, 21. 28, 0, 14, 21. That would be the answer if it let us actually do it right. It's not going to show us. Let's take a look. There's the answer, 28, 0, 14, 21, which is exactly what we had, but it won't count it right because it gave us the wrong size matrix. So we know we can't complete this 4 out of 4, no possible way. The next one that gave us one is correct. See, so, but we know we can't get 4 out of 4. So we turned in the picture of the bad answer, and we will get 100%. All right. We're finished with that folder, but we need another folder before we take the quiz, because there's some things we need to learn about zero matrices. Because there's a question on the quiz that most, I'm not going to say most people, but is most missed. If there's a question that's missed, it's the same question over and over again. So we're going to look at this before we get to the quiz. All right, close this down. Again, starts with what is a matrix? This is a 2 by 3 matrix. All right, let's define a zero matrix. And you might have already guessed. If I would have said zero matrix, you probably already guessed what it is. A 3 by 3 zero matrix is a matrix we usually call by the name of O or 0, and it's all zeros, and it's 3 by 3. Or a 2 by 4 zero matrix is all zeros in a 2 by 4 matrix. Right? So we can have a zero matrix any size we want it. Any size we want it. We just make it, excuse me. We just make it whatever dimensions we want it to be and fill it in with zeros. And let's look what happens when we add a zero matrix. So if we have this matrix, 4, 5, 1, 3, and we add a zero matrix to it, can you take a wild guess at what it equals? Yeah, it equals exactly what you think it equals. Because when you add 0 to 4, you get 4. When you add 0 to 5, you get 5. It doesn't change a thing. Right? So adding a zero matrix to another matrix is exactly like adding 0 to a different number. Anytime you add 0 to a number, nothing happens. Okay. Same thing here. We have a 3 by 2 zero matrix being added to a 3 by 2 matrix, and the matrix is just exactly the same as before because we added nothing to it. So basically, when we add an m by n zero matrix to any matrix A, we get matrix A. So A plus 0 equals A, or 0 plus A equals A. This doesn't give the dimensions of the zero matrix, but it's just understood that the dimensions of the zero matrix will match whatever matrix A is. So here's a good question. If we were to add a zero matrix to this, B plus the zero matrix equals B, what are the dimensions of the zero matrix? If it doesn't tell us. Well, the dimensions of the zero matrix have to be identical to matrix B because that's the only way we could add it to it. Remember, we can only add matrices that are the same dimensions. So it would be a 2 by 3 since B is. All right, what happens when we add opposite matrices? The opposite of matrix A is the matrix negative A, where each element is the opposite of the element in matrix A. So, for example, if A is 4, 1, negative 6, 2, then negative A would be negative 4, negative 1, positive 6, negative 2. Same numbers, just the sign is the opposite. So look what happens when we add opposite matrices. If we have 4, negative 3, 8, and 7, and we add negative 4, 3, negative 8, negative 7, we get a zero matrix. Because 4 plus negative 4 is 0, negative 3 plus 3 is 0, 8 plus negative 8 is 0, 7 plus negative 7 is 0. And that kind of makes sense, right? If we add any number to its opposite number, 10 plus negative 10, we get 0. 3 plus negative 3, we get 0. So we end up with a zero matrix. All right, so it has another one. When we look at this, we can see it has the same numbers, 4, 2, 5, 1, 3, negative 2. It's just they have the opposite signs in the two matrices. This is negative 4, this is positive 4. This is positive 2, this is negative 2. Positive 5, negative 5. So when we see that, we're like, oh, this is going to be a zero matrix because all of these numbers are just opposite signs, but the same number. Check. So in conclusion, anytime you add a matrix to its opposite matrix, you'll get a zero matrix. And also, if you subtract a matrix from itself, A minus A is a zero matrix. What happens when we multiply a matrix by the scalar 0? 0 times 5491. Just what you expect. 0 times 5, 0 times 4, 0 times 9, 0 times 1. Right? And here, even though it's a larger matrix, it's 0 times every number in the matrix. So 0 times negative 2, 0 times 4, 0 times 10, 0 times 7, 0 times negative 1, 0 times 5, 0 times negative 3, 0 times 4, and 0 times 2. Okay, I'm just kidding on that one. It's not 542. It's a 0. Yeah, 0 times any matrix will give you a zero matrix of the same size. So in conclusion, 0A will always equal a zero matrix, regardless of what size. Let's compare the zero matrix to the real number 0. If we have the real number 0 and we have a number A, let's say A is 7, and we add 0 to it, we'll get 7. Okay, that makes sense? If we have a matrix A and we add a zero matrix to it, we'll get A because it doesn't change matrix A. If we add a number to its opposite number, we'll get 0. So if we have A is 7, all right, Coop, if A is 7 and we add negative 7 to it, we'll get 0. Well, if we have matrix A and we add negative A, which is all the same numbers, just with opposite signs, we'll get the zero matrix. Any number times 0 is 0. 7 times 0 is 0. Any matrix multiplied by a scalar 0 would multiply every number inside matrix A by 0 and give us the zero matrix. All right, so that is that lesson. So that'll help us in the quiz. Let's go back to the next lesson. Properties of matrix addition. Okay, let's look at the properties of adding matrices together. All right, the properties of math still apply with matrices. Like we know the cumulative property of addition. A plus B equals B plus A, right? 3 plus 6 equals 6 plus 3. Doesn't matter which order we add them in. That's true with matrices as well. The associative property of addition. A plus B plus C is the same as A plus B plus C. If we have 1 plus 2 plus 3, we can add 2 plus 3 together first to take 1 plus 5. We still get 6. Over here, we can take the 1 plus 2 before we take plus 3. 1 plus 2 is 3 plus 3. We still get 6. So 1 plus 2 plus 3, it doesn't matter which 2 we add together first. We can even add A plus C together and then add the B. It doesn't matter. And that's the same with matrices. The additive identity property. For any matrix A, there is a unique matrix 0 such that A plus 0 equals A. The 0 matrix. There is a matrix to match any matrix. And when you add it to it, you get nothing. And that's the same thing with numbers. If we have 7 plus 0, it's going to equal 7. The additive inverse property. For each A, there's a unique matrix negative A, so that A plus negative A is the 0 matrix. 7 plus negative 7 is 0. And then the closure property. We don't talk about the closure property very much. All right, back. Good job, Coop. The closure property means if we add A and B, and A is a 2 by 2 matrix and B is a 2 by 2 matrix, the answer is going to be the same dimensions as A and B. The closure property says, okay, I'm going to open up these different bags of matrices. Here I have a bag of 2 by 2 matrices. Here I have a bag of 3 by 3 matrices. Over here is a bag of 4 by 4 matrices. If I pull 2 matrices out of one of those bags, hey, these are both 3 by 3 matrices, the answer is going to come out of the same bag. It's closed. There's no way I can branch over and grab a 2 by 2 matrix as the answer. If I'm adding a 3 by 3 and a 3 by 3, the answer has to be a 3 by 3 also. That's what the closure property says. It's closed. Whatever those 2 matrices are, the answer is going to be the same size. It's closed. There's no option to go different. That's what the closure property says. A and B is a matrix of the same dimensions as A plus B. So we're going to explore those properties a little bit, starting with this is a 2 by 3 matrix again. And if we add 2 matrices of the same dimensions, we will get a matrix of the same dimensions, 2 by 2, 2 by 2, and we end up with a 2 by 2. Here's where they did the math. All right, so there's links back to the previous lessons if you need help with any of that. Okay, so notice that the sum of 2 2 by 2 matrices is another 2 by 2 matrix. This is the closure property we're just talking about. Any 2 m by n matrices added together is going to be another m by n matrix. If the dimensions of the 2 matrices are not the same, addition is not defined. You cannot add them together. So we know if we had 2, 7, 8, 2, 4, 3, and we want to add 5, 2, 8, 1, we cannot do it. It's undefined. Because one's a 2 by 3 and one's a 2 by 2, that can't work. So let's look at each property individually here. So the commutative property, where we said A plus B equals B plus A, where we said 3 plus 5 is 5 plus 3. Either way, you get 8. That also works with matrices. If we have 3, 7, 2, 4, and we want to add 5, 2, 8, 1, we can take 3 plus 5, 7 plus 2, 2 plus 8, 4 plus 1. Or if we wanted to reverse them in the other order, it'd be 5 plus 3 instead of 3 plus 5. It'd be 2 plus 7 instead of 7 plus 2. But either way, we're going to end up with the same answers because 3 plus 5 and 5 plus 3 are the same number. 2 plus 7, 7 plus 2 are the same number. So really, it could be the same as this, 5, 2, 8, 1 plus 3, 7, 2, 4. You can reverse the order. Doesn't matter. It's commutative. The associative property, A plus B plus C equals A plus B plus C. So we can take 2 plus 3 and then add 5 to it, or we can take 3 plus 5 and then add 2 to it. But either way, we get 10. Well, looking at matrices A, B, and C, we can add A and B together first. 5 plus 3, 2 plus 4, 2 plus 9, 8 plus 6, and then 1, 0, 3, 7. But we get 5 plus 3 plus 1, because we added this afterwards. Or we could have added these two together first and get 3 plus 1 and add 5 to it. See, 5 plus 3 plus 1 or 5 plus 3 plus 1. It doesn't matter if we have three matrices added together. Doesn't matter which ones you add together first. Additive identity. A zero matrix, denoted as this, an O, is a matrix in which all the entries are zero. And notice when you add a zero matrix to any matrix, you just get the original matrix. 3, negative 179 plus 0, 0, 0, 0 equals 3, negative 179. Or larger matrices. Does not matter. The additive inverse. If we have A is negative 2, 8, negative 3, 1, then negative A would be positive 2, negative 8, positive 3, negative 1. And we add those together, we get the zero matrix because you're adding opposite sign numbers together. All right. Oh, I like this. Choose all the answers that apply. There may be more than one answer. Which of the following matrix expressions, and these are all A, B, and C, are all 2 by 2. Okay, that's important. Which of these are the same as A plus B, parentheses, plus C? A, B, C, and D. There's more than one answer. Tell me what they are. Which of the following matrix expressions are equivalent to parentheses A plus B, parentheses, plus C? There's more than one correct answer. Can't it be all? It could be all. The parentheses are solved first, like in this one up here, you would add A plus B, and then you would add C to it. In this one, we'd add C plus B first, and then add A to it. This we'd add C plus A, and then add B to it. This we just add them in order. And then this is add A and C together, and add B and C together, and then add those together. So if you need to, just replace these matrices with numbers. Say 2, 4, and 6. So in this one, we'd add the 2 and the 4 together, and then add 6 to it. 2 plus 4 is 6, so we get 12. So if we add 4 plus 6 is 10 plus 2, that's the same. If we add the 2 and the 6 and then add 4, that'd be the same. If we add 2, 4, and 6, that's exactly the same, doesn't matter in parentheses. But this adds the 6 twice. This adds C twice. So it can't be D because that doubles the C. A plus C plus B plus C. We've already got C added in there. So that's adding C twice. Yes, it's just A, B, and C. Oh, this was a good one too. Which of the following matrix expressions are equivalent to A plus negative A plus B? And they're all 2 by 2 matrices, so that's important. A plus negative A plus B is the same as what? And they're all 2 by 2. Is that a little tricky? Jonathan says, well, that'd be the same as this because we just move the negative A and add it to the B first, and then add it. So that should be the same. And A plus negative A, well, that's the 2 by 2 zero matrix. So it could be C. This is a 3 by 2 matrix. There's no way we can add a couple of 2 by 2. So it can't be this. But what about A? Is it equivalent to just whatever B is? Because if it's equivalent to C, which is saying add a zero matrix to B, adding a zero matrix to B means it's just B. As we know, adding a zero matrix does not change what B is. So again, we have A, B, and C. Very nice. But this is the wrong size zero matrix. That won't work. All right, that's the end of that lesson. All right, we have one more, properties of matrix scalar multiplication, and then we'll have our first quiz, which I need to look at. Because I think there's a question on there that we haven't covered. I didn't fix that, I don't think. I hope. I'll look at it. Close. Okay, so we're looking at the properties of matrix scalar multiplication. There's the associative property of multiplication, which says C times D times A is the same as taking C times D times A. You can move the parentheses. If we're multiplying three things together, it doesn't matter which two you multiply first. Distributive property, if you have C times, and then A plus B is in parentheses, that means you take C times A and then add C times B, because that's how we distribute. Or if you have the parentheses first, C plus D times A, just take the C times the A and the D times the A and add them together. Oh, the multiplicative identity property. And we need to talk about this because I know there's something on the quiz there. 1 times A is 1. The identity property just means you get what you started with. It's just multiplying by 1. And there is a matrix. There's an identity matrix that just multiplies a matrix by 1. Multiplicative properties of 0. 0 times A is 0, or C times a 0 matrix is 0. So we know how multiplying by 0 works. And the closure property. If you multiply a scalar number times a matrix, the answer is always going to be the same dimensions. Whatever the matrix is going to be the same as scalar times the matrix. So let's look at this. If a scalar times a 2 by 2 matrix is multiplied by a 2 by 2 matrix, you'll get a 2 by 2 matrix. There's no way you can get anything but. A scalar times a 2 by 2 matrix will be a 2 by 2 matrix. This is the closure property. There's no way we can multiply a scalar times a 2 by 2 matrix and get a 3 by 4 matrix. It's not possible. Because scalar multiplication relies heavily on real number multiplication, many of the multiplication properties we know to be true with real numbers are also true in scalar multiplication. So let's look at the associative property. If we have two scalars, C and D, and we're going to multiply them times A, we can multiply them together first. And that would be the same as just multiplying one scalar times A and then multiplying the other scalar times A. It works just the same way. So let's look at this example. If we have a scalar of 2 and a scalar of 3 and a matrix of 5, 4, 8, 1, this illustrates both ways. We could take the 2 times 3 and multiply them to first, so it would just be 6, and then have 6 times 5, 6 times 4, 6 times 8, and 6 times 1. So we'd have 30, 24, 48, and 6. Or we could take the 3 scalar, multiply it first times the matrix, 3 times 5, 3 times 4, 3 times 8, 3 times 1, and then multiply it by the other scalar. So over here where we had 6 times 5 was 30, here we have 2 times 15, which is also 30. Here we had 6 times 4, which is 24. Here we have 2 times 12, which is 24. 6 times 8 was 48. 2 times 24. 6 times 1 or 2 times 3. It works the same. The property works the same with matrices as 2 times 3 times 5 being the same as 2 times 3 times 5. The distributive property, if we have a scalar of C and 2 matrices, it says we can add those matrices together first, since they're in parentheses, and then multiply them times the scalar. Or we can distribute the scalar, multiply it times the first matrix, multiply it by the second matrix, and add those matrices together. So in this first example, we would end up with 2 times 5 plus 3, because we add the matrices together, 5 and 3 are the same element. So that's 2 times 8 is 16. Over here, we distributed. So we did 2 times 5 and 2 times 3 and added together. 10 plus 6. So we still get 16. So with each example, you can see you end up either way with the exact same answer. So this property holds true. So that's the same thing there. Or if we have 2 scalars being added together times a matrix, we could distribute the matrix to both of those and add it together. Let's look at both ways. If we have 2 and 3 and this matrix A, we could add the 2 plus 3 together first and then multiply by the matrix, or distribute it. 2 times the matrix plus 3 times the matrix. So the first number, 2 plus 3 is 5, times 6 is 30. Over here we got 2 times 6 is 12, 3 times 6 is 18, 12 plus 18 is 30. So it'll hold true either way. The same properties that work with numbers also work with matrices. The multiplicative identity property. If you multiply by a scalar of 1, you'll end up with the exact same matrix you started with. 1 times 2517 equals 2517, because it's 1 times 2, 1 times 5, 1 times 1, 1 times 7. Same way in that 1 times any number equals that number. Multiplicative properties of 0. 0 times a matrix equals the 0 matrix. Right? 0 times 3867. Multiply every number by 0. You get 0, 0, 0, 0, or a 0 matrix that is the same size as the original matrix. So C times a 0 matrix equals a 0 matrix. If we have a scalar being multiplied times a 0 matrix, 3 times 0, still going to be a 0 matrix. All right. Which of the following, we just have 3 choices this time, are equivalent to C times 1A plus B? We got a lot going on here. We have a identity matrix, 1A. We've got A plus B, 1A plus B being added together in parentheses, and we have a C on the outside. There's a lot going on. Which of these is that equivalent to? A, B, or C? Or A, B, and C? Or A and B? Or B and C? Or A and C? You got choices. What do you think? We're about to be done with this and look at the quiz. We just got to get through the last few problems. Which of the following equivalent to C times parentheses 1A plus B? Well, we know we can distribute the C and do 1AC plus BC. 1AC plus B. Oh, the C never got applied there. It can't be the first one. 1AC plus BC, but where's the 1? Well, we multiplied it. 1 times A is just A. So CA plus CB is going to be right. And if we can do CA plus CB, this is the same thing, just reversing them. It's all good. Which these is equivalent to multiplying the scalars together times A plus 0A. So can we factor out the A like this? Each of those have an A, and we can put these together, CD plus 0 times A. That should be the same. 0A just disappears, right? That's a 0 matrix. It doesn't change anything when we add it to this. So C times D times A could be the same as C times D times A. This goes away. But this just ignores the CD. Can't be that. All right. Let's look at the quiz, because there was a problem with the quiz before too. Looks like the quiz is working. Okay. Oh, good. Okay. So in Buzz with the quiz, ignore this line right up here, this BEG. This is This tells Buzz to display a matrix with those numbers. So this is what you're looking at, just the matrix. What are the dimensions of this matrix? That's a big one. What is the 2, 3 element in this matrix? Multiple choice. How would you write this systems of equation as a matrix? Multiple choice. Perform this row operation. R1 plus 4R3 becomes R4. So that would be which one of these four? In the following matrix, X equals and Y equals. Type in the number. No spaces, just the number. So you got to find the X. There's the X. Do the math. 1 plus X equals -2. Here's the Y. 7 plus 8 equals Y. I like this one. If X is a scalar and X times -1,0,3, 2.3 equals 3, 0, -9, -6, 9, what is the value of X? What is the scalar? No spaces, just type the number. And if A and B are 2 by 2 matrices and C is a scalar, based on the properties of scalar multiplication and addition, which the following is equivalent to this. This is what we were just doing. C times A plus 0B. Select all correct answers. That's the important part of that. There may be more than one correct answer. All right, 7 questions. 7 questions in quiz 1. So that's what we got this week, guys. We have 2 assignments, and then you have those 3 lessons that prepared you for this quiz, because we cover some things in those lessons. Quiz 1. So that's the 3 things we have this week. You should have time to get them done before your next class, because these don't take very long. So I'll let you have the rest of the class to finish up these matrix assignments, and then we'll be ready to go for next week, which means you're 1 week closer to graduation. There ain't much time left. Yippee, yippee. We're all happy about that. All right, guys. If you need help, let me know. Otherwise, have a great week. It is an A day, so I'll be here Wednesday and Friday.